Hello, so I'm back doing properties of multiplication, and some of them are the same. The commutative property, associative property, identity property, property of 0, and property of -1. Some books also publish the inverse property, which I think actually belongs more with division. But that's my personal opinion, because if you're doing the inverse property, it's 1 over a, and in order to get to 1 over a or its reciprocal, you have to divide first, and in my opinion, that's more of a division, because the division is actually the first step in order to get to that multiplication. But I suppose that's argumentative, and some people might disagree. But in my personal opinion, I agree with that. But enough with semantics, on with the show. So I'm going to talk about the properties of multiplication and how you actually use them. And the commutative property is still the same. It's a times b equals b times a. Before we were doing addition, but now we're doing multiplication. And when I think about commutative property, and I don't know if I neglected it, I think about commuting. And what I mean by commuting is if you're commuting, you're traveling. You're moving things around. Well, that's exactly what you're doing here. You're moving the a and the b. They're switching order. Now, how is that useful, or how is that practical when you're doing basic multiplication? Well, I'll go ahead and show you. Because, again, this is how I think my mind works, and a lot of other people's too. And it's good to know how your mind works. So I have two numbers. I have 10 times 6 and I have 6 times 10. They're both equal to 60. But if you ask me what 10 times 6 is, and I had to count it on my fingers, I go 10, 20, 30, 40, 50, 60. Answer is 60. And it's really easy for me to do it. I wouldn't count it in my fingers. I've been practicing long enough, but I used to do that too. And when I do 6 times 10, when I was first learning it, I go 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Now both answers are the same, but which one is the easier of the two to multiply, even though it's the exact same problem? And it's brilliant because 10 times 6 is, and it's telling you that if you're doing two problems, if you're multiplying 12 times 10 and 10 times 12, switch the 10 and the 12 and make it 12 times 10, and you'll be able to know that it's 120. That's what the commutative property of multiplication means. Something pretty interesting. I'll show you the associative, which actually will make you look brilliant if you use it right. And I'm going to use two specific numbers. One of them is going to be used twice. I have the numbers 9. Again, I'm going to write underneath here because I ran out of room. They're both equal. 9 times 9 times 2, 9 times 9 times 2. But the order of operations is telling me to do 9 times 2 first on this problem and 9 times 9 on this problem. Now if I look at this, I know the answer is 162. Not because I looked at it right away, but because I just kind of figured it out. 9 times 9 is 81. A basic math fact that most students should know before they enter high school. 81 times 2, or double 81, is 162. If I do this first, 9 times 2 is 18, a lot less people are going to know that 18 times 9 is 162, but they will know that 81 times 2 is 162. And people use that all the time. In fact, a particular place I was working at, I used to use that when people were, calculating things, some sort of data, for instance. And they said, well, we have this many, and we're dividing it by this many. What's the answer? And I would just say it out loud, and then somebody said, well, how did you figure that out? Or if they multiplied it, well, I don't know how you multiplied it so fast. Well, what I'm actually doing is I'm using the associative property. I'm not telling people I'm using it, and I don't tell my mind to use it. My mind just kind of automatically triggers it. But that comes because I practice it so often that it's kind of second nature. I guess it's like I'm not good at basketball, for instance. I wish I was better, but I'm not. But it's like somebody who can make a shot without really even trying, and I have to sit there and practice for 2 hours just to get a consistent rhythm going. It's kind of the same thing. Different people have different strengths, but at the same time, that person practiced basketball much more often than I did, and I probably practiced math much more often than they did. So my math skills will probably be sharper because I did all that practice, and their basketball skills will be sharper because they practiced much more basketball than I did. So, although I suppose that's arguable too, but whatever the case. Next one I have is a times 1 equals a. And basically that's the identity property in multiplication. And all that means is this. If I take the number 7 and I multiply it by 1, answer is 7. That's it. The zero property, or the property of 0 in multiplication, means if I multiply by 0, my answer is 0. 7 times 0 is 0. Anything times 0 is 0. And the last one is the property of -1. And 7 times -1 is -7, but it also works in the other way. Let's say I have a negative number, and I multiply by -1, it's going to change it to whatever it was. Now somebody would say, well, that doesn't make sense because here it's positive and here it's negative. No, this is a variable. I can substitute anything I want in. It's just going to be the opposite of that variable. So if I substitute in a negative number, it's going to be positive. If I substitute in a positive number, it's going to be negative. Those are the properties of multiplication. I hope that made sense and maybe a couple of those tricks worked. Other than that, have a great day for now. Goodbye.